So there are multiple things I want to discuss. I think I'll start with this paper here. When organizational identification and control prevent sharing scientific discovery. I wrote this, I put it on Vixar on November 22nd, but it took me a little while to write this because this was for one of my classes. The abstract is as follows. A short overview of how academics control each other and some flaws induced by too much identification, control, and discipline. It is argued in research that too much of all three latter concepts can counteract the stated goals of teams in large organizations. In fact, too much identification, control, and discipline reduces quality, stamps out creativity, and decreases employee involvement. This can lead to peer review, reinforced groupthink, and the overall stalling of progress in science and of sharing scientific discoveries. As well, it shows that resistance to discoveries is rooted in cultural norms and shared misguided definitions. And I'll let you guys read it yourself, but the basics of it is when you have a team of people inside of an organization and you have a goal, you go for the goal, right? You go for the task at hand. But what's happening now in science and astronomy, their goal is to find exoplanets, which is a reasonable goal. They're finding all of them. But the discipline and control methods they use to publish the results, there's no room for them to interpret the information in a creative light, because that's auxiliary to their main goal. Their main goal is to find it. As well, if they were to try to publish alternative understanding of what it is they're looking at, creative ideas, then it'll make them stick out and you won't be able to do the research in finding whatever it is that you're looking for. For instance, if somebody like me were to be in charge of a new space telescope hunting these things down, I couldn't sit there and say, well, looking for exoplanets is easy because the young ones are bright, they shine, and we call them stars. I would get laughed out of the boardroom. There's no freaking way. There's no way creative ideas can be allowed to thrive inside of an organization that pushes discipline and pushes a specific type of culture, and that only allows for their methods to work. In other words, the ideas and the methods they say makes the organization work sometimes can be bad for the organization, because sometimes what you need to make the organization thrive and achieve its goals and understanding what it is they're trying to do in the long run is explain how the hell these exoplanets form, means you have to discard all those organizational structures that are designed to keep you guys in a straight arrow and keep you guys goal oriented. In other words, the type of culture that they put on a pedestal can be a double-edged sword and prevent them from understanding how nature actually works. And that being said, there are different types of controls. For instance, there's bureaucratic control, where you have to do lots of paperwork and you have to apply for grants for funding and stuff like that. And you have to make it look like you're an expert in your field, or else you're not going to get any money. They're just going to who the hell is this person? And that's not a problem I have, because a lot of information I can gather without having to go through any type of bureaucracy. It's readily available online. As well, the basics of star evolution, which is planet formation, are easy to explain and do not require any type of acceptance into a larger community. You can just do this on your own, as you can see with these videos. For those that are new to this theory, the theory basically says You have young stars being born, they expand outwards, they get to their greatest size, and then they continue, and then they start losing mass and evolving slowly and becoming what are called planets. Meaning stars and planets, they were never mutually exclusive, but the organizations, the universities, the research organizations around the world, they teach that these objects are mutually independent of each other. They say that a baby and an adult man are not the same thing. They're different species, so to speak. But clearly, the baby will become the grown man or the grown woman. And that's basically what we're looking at here. We're seeing a bunch of bright babies, and then the astronomers say, well, no, they're not related to the grown men or the grown women. These are different than these. But my listeners know better. As well, 2011 was when I started this theory, but Alexander Oparin, the Soviet biochemist, one of his statements here, this is translated because he didn't write this in English, it was in Russian, but this is translated here. I want to read it out to you, and then I'll tell you how long ago this was thought up. Depending on a number of factors, mainly on the size of the cloud, the process of solidification might occur quickly or slowly. The different heavenly bodies are now, therefore, at different stages of development. Some of these stars shine with a white or bluish light and are in the earliest stages of development. Others, which have developed further, are yellowish, and our sun is one of these. Finally, the stars, which have cooled most and are already going out, shine with a red light. A further stage of cooling is represented by the planets, which can no longer shine with their own light. Our Earth is one of these. Thus, a study of the different heavenly bodies gives us an idea of the different stages of cooling of our own planet. Now, this was written before 1921. I think this paper was written in 1921, which means the idea came about before 1921. The idea, I call it stellar metamorphosis, is over 100 years old. This is a very old theory. This theory is far older than me. And it just stinks sometimes because astronomers, they sort of only look at the history of things, like this history of science. They only look at the history of science for the ideas that have survived all this time. They don't look at the history of science in the light of, hey, maybe some really great ideas existed in the past and we just completely neglected them, we forgot about them, and we just brushed them under the rug as if they were wrong. This is one of those ideas where the astronomers really, really screwed up bad. Really bad. And one of the reasons why I sort of look at this and I say, well, how could astronomers, being that Alexander Oparin was a biochemist, how could they have screwed up so horribly in making two different classes of objects when essentially they're the same? Well, he was in Soviet Russia. His career was coming up during Linsekoism, when a lot of that pseudoscience was being pushed about, how crops could be grown, and it was just a total catastrophe. And he just sort of kept his head down so he could, keep on going in his career and keep on doing what he wanted to do in life. And that's one of the main things in this paper. I don't talk about Alexander Oparin in this paper, the organizational control and the bureaucracies that stamp out creativity, which in turn reduces quality and makes teams fearful of others stepping out of line with what the status quo says is true, regardless of how wrong the status quo is. So basically what happened is Alexander Oparin had these great ideas, and to perpetuate his career, to keep on working up, he just sort of put him on the back burner and just, everybody just forgot about him. And then the United States astronomers and European astronomers, they were working on classifying the stars based off their spectrums, and they just went off tangent with classifying only stars as the objects that have spectrums and determining what's happening to them. And then they look at planets, and then we didn't have any planets. We only had the planets of the solar system. So there wasn't enough data, as well as they were collecting too much data. It became lopsided. They were collecting too much data on spectroscopic measurements of stars and classifying stars as only the ones that shine. And they only had the 9 planets of the solar system, which are these dim, gaseous, and rocky objects that were just totally unstar-like, at least in their eyes. So what's happening now is that really heavy, really data-intensive information that we've collected over the past 100 years when we started to take measurements with telescopes and whatnot, that's finally being balanced by the discovery that planets are ancient stars, and the scale is tipping to the other side, and we're realizing that it's actually a long continuous process between the young stars that have spectrums and that can be measured with, measured easily, and then those spectrums sort of diminish and dim and dim and dim and dim, and their characteristics, the star's characteristics change, and they go through many, many, many stages of this evolutionary process, which leads astronomers to continuously, still call them planets and exoplanets, but no, they're stars that are evolving at specific rates. As well, it says here, depending on a number of factors, this is Oparin's, depending on a number of factors, mainly on the size of the cloud, the process of solidification might occur quickly or slowly. And that was one of the ideas that I had for depending on the size of the cloud. Well, yeah, all the planets, they start up pretty freaking massive, okay? And depending on how much material it's kept and how fast it evolves will determine how big it can get. If it evolves very slowly, it goes up, it becomes a large object because it collects a lot of material and it keeps a lot of it. If it evolves really fast, it becomes a really, really, really small object, and it can never really form a life on it because the chemistry and the huge volume of the star, there's not enough of it happening to randomly produce things like amino acids and eventually cells and all that extremely complex stuff. And the main root of this idea, the origin of life paper, this is page 15. It says here, he also writes, in the course of the colossal length of time during which our planet, the Earth, has existed, the appropriate conditions must certainly have arisen in which there could have been the conjunction of properties which were formerly disjointed to form the combination which is characteristic of living organisms. To discover these conditions would be to explain the origin of life. And Alexander Oparin, he was on it. He was drawing a bead on the truth of how life formed. And finally, we can sort of follow where his mind was going with the discovery of exoplanets in different sizes. And we can fill those gaps with how Earth was in the past. And the chemistry of these objects is directly related to the formation of life. And we need to study these objects, Jupiter, Saturn, Uranus, Neptune. They are pre-Earths, and they're very young pre-Earths. The Uranus and Neptune are older than Saturn and Jupiter, and Saturn and Jupiter are a lot older than the youngest, brightest stars. But we can look at these objects now and reason effectively as to why life is how it is, why the chemistry is how it is on the Earth, why there are oceans, why there are rocks and minerals in crystalline form, why all this is occurring, why all this is the way it is. And it really is totally incredible that I should be able to be on the same level as Alexander Oparin. And I don't even have a degree in biology. I don't have a degree in chemistry or physics. But you don't really need one to understand these types of concepts. Sure, if you want to get into the details and go overboard with that, you need to get, degrees to show that you know what you're talking about. But even then, you don't really need a degree. You can go to the public library or a book sale and buy a book on biochemistry and just read it and teach yourself. What is it called? Autodidactic or something, where you're self-taught. That's basically how I've come to realize a lot of things. And yes, I've taken physics and geology and chemistry and biology and all that in college, and I got A's in those classes. But the actual delve into the details isn't necessary, because the real big picture is very simple, and it doesn't require years and years and years of schooling to understand. What actually happens is that years and years and years of schooling can prevent you from understanding the very basics of astronomy. And unfortunately, that's just how it is these days. And I've been talking to Mickey, and we've been discussing how exactly do we get into the mind of somebody who's indoctrinated so intensely indoctrinated. Once these geologists, they leave their 4-year bachelor's degree, and then they go to get their master's, and then maybe they get a PhD, the chances of them really doing an about face and examining their assumptions, it diminishes the more and more educated they become. So in essence, I don't know if we're going to be able to reach indoctrinated minds. It's just going to be too difficult. It's going to be too emotionally overwhelming for them. The only real way we can really reach people is if they haven't been indoctrinated yet, because they don't have all those ideas that have to contend with the status quo yet. They don't have all those ideas. Anyways, I just want to show you that. I'll link Alexander Oparin's page in the bottom, and just sort of understand that this is a very complex issue. It isn't just about teaching people what the Earth actually is. It's about looking at the history we've forgotten or ignored, as well as it's trying to understand how people in larger communities spread ideas, and even the ones that are most well-intentioned and perceivingly on a goal-oriented path, those people in specific could be the ones that are actually off the track, so to speak, and just are completely lost. So in that case, the appearances, they can be deceiving. Some people who look like they have everything figured out are the ones that are the most lost. And in this case, astronomers, that's true. They're the most lost, and they're actually off the tracks. Their train is completely wrecked. It's all over the map, or all over the field. It's a train wreck. Their theories are a train wreck. But anyways, I think I've made this talk long enough. Take it easy, y'all.